Hello everybody. Today we are going to continue on with our discussion of chapter 2. Yesterday we distinguished between the difference of speed and velocity and defined both quantities. Remember, speed is a scalar, velocity is a vector. Today we focus in on acceleration. Acceleration is given the symbol lowercase a with the vector sign above it. Please don't use an uppercase A, as that's the symbol for amps, which is a totally different thing. The definition of acceleration is the change in an object's velocity. Because it's the change in velocity, it is a vector quantity, as I said. The equation for calculating acceleration, for now, is that acceleration is equal to the change in velocity per change in time. You can also write this as final velocity minus initial velocity, because that's the same thing as change in velocity, divided by time. Now, units are meters per second squared. I talked about in class today that a lot of times people will call this meters per second because velocity is in meters per second, time is in seconds, but meters per second is the same thing as meters per second squared. So the rate of change of velocity is another way of defining acceleration. All right, now that we've established a working definition of acceleration, how can an object accelerate? There are three main ways. The first one is for an object to speed up. Honestly, that's the most common definition used, and what probably comes to mind when I say a car was accelerating, you picture it speeding up. However, if the definition is just the change of velocity, technically slowing down is also a form of acceleration because the velocity is changing from a higher value to a lower value. Now, the third way for an object to technically accelerate is for it to change direction. Because velocity is a vector quantity, therefore, if you change the direction, you change the velocity. Because remember, vectors are specific quantities directed in a particular direction, I guess. So an example of that would be if you had like a carousel or a Ferris wheel. As long as it's moving in a circle and changing its direction, it is technically accelerating, even if it's moving at a constant speed. All right, a couple of other statements that are true that I'd like to discuss with you. These statements are true, but at first they might sound false or a bit complicated. So the first one is that negative acceleration can mean that an object is slowing down, which is what you probably think of. But it can also mean that an object is speeding up, just going in a negative direction. So maybe it's moving towards the west or moving south or downward. That can also technically be negative acceleration. The other statements that I want to discuss are when an object's velocity and acceleration are in the same direction, the speed of that object will increase with time. I mean, if you are in a car moving in a forward direction, you press on the accelerator, the gas pedal, it's going to move you forward and you will speed up. Now, the second caveat is when velocity and acceleration are in opposite directions, the speed will decrease over time. How in the world does that happen? Okay, so let's think about a car. My car is not all that beautiful here, but you got a car and it's driving down the road. All right, so it is headed this way. So its velocity is forward. But what happens when you want to slow down? You apply the brakes, and the brakes are going to apply a force in the negative direction. So in this case, the acceleration vector is actually headed backwards compared to your velocity. So it's a negative acceleration and a positive velocity. A real life example of this is if you think about when you're in a car, if there's a deer or something that runs out in front of you and you slam on your brakes, the car doesn't instantly come to rest. That takes some time. And frequently you'll see skid marks left on the roadway. So you know your velocity was still going forward. You're moving forward, but the brakes are slowing you down and causing you to eventually come to a complete stop. So that's what that would look like in real life. All right, let's do one sample problem here. Let's say in one of the word problems says in 1977 off the coast of Australia, the fastest velocity by a vessel on the water was achieved. If this vessel were to undergo an average acceleration of 1.8 meters per second squared, it would go from rest to its top velocity in 85.6 seconds. What's its top velocity? Okay, so things that I just told you, let's write them down. The acceleration that this vehicle is undergoing is 1.80 meters per second squared. We know that it's going to start at rest, so its initial velocity is 0, and then it's going to take a time frame of 85.6 seconds to reach that top end speed. So let's go back and look at our equation here for acceleration. They are asking us to find how fast would it be going at the end. Okay, so we need to find BF. Okay, so our equation says acceleration is equal to BF minus VI over T. Now, I frequently tell people to go ahead and drop out any terms that are 0. Since the initial velocity is 0, we can cancel out that term. So this is going to be rewritten as acceleration equals final velocity over the change in time. And if I want to solve for the final velocity, I've got to isolate it. So I need to get time away from that side of the equation. So the opposite of dividing is to multiply. And whatever you do to one side, you must do to the other. So now this tells me that the final velocity should be equal to acceleration times time. Now we should make sure that our units agree. We've got seconds and meters per second squared, so that is allowable. So our final velocity is going to be equal to 1.80 meters per second squared times 85.6 seconds. And I have that the top end speed or final velocity of that vessel is about 154.08, and our unit label would be meters per second. All right. I hope this helps you understand what acceleration is. Please don't forget that there are technically 3 ways to accelerate: speeding up, slowing down, and changing direction.